Hi everyone, we are back, and the next speaker is actually from Deep Knowledge Group, Mr. Iho Kandyukov. Welcome to Deep Tech Forum, Iho.
Welcome, Rico. Hello, everyone, and it's my pleasure to be here and hold this talk. And the topic of my talk will be algorithms and data for deep tech investment analytics. With that, I'm starting my presentation. So the key point is that kind of various deep tech industries are booming now. And what we are focusing on are AI for drug discovery, so artificial intelligence for drug discovery, longevity industry, fintech, govtech, and space tech industries. And the growth of funding in these industries is measured in most cases by dozens of percent annually, and in some cases, as it is for pharma, it's hundreds of percent annually. And in order to deal with this enormous amount of incoming data, we have developed so-called big data analytics dashboards, which you can observe on the screen, and where we aggregate our deep tech industry analytics. And what I'm going to talk about today is how we aggregate the data on the deep tech industries, how we analyze it using various artificial intelligence and machine learning algorithms, and how we visualize it so that it can be readily available for investors, companies, hubs, and government agencies. And just a couple of slides for illustrations, what's going on there, how we present our results, or in the form of big data analytics dashboards. And yeah, as in the previous slides, you could observe AI and pharma dashboard, whereas here we have longevity industry dashboard, where we have interactive mind maps, industry database, interactive network diagrams, and competitor matching tool. And basically, during the last several months, we have managed to collect almost 5 million data points representing parameters of the companies, investors, and hubs in the longevity industry, and apply it for the automated SWOT analysis of these entities. Basically, what we are to show more tangible results here, what we are doing, we are doing automated SWOT analysis system, which covers most of the companies and investors and in the AI pharma industry and in other deep tech industries such as longevity, space tech, neurotech, and fintech. Basically, the results of the functioning of these algorithms you can observe on these slides. And what you see here is basically SWOT analysis of business development, of various aspects of business development of AI in pharma companies, which is represented into 12 vectors of the development. And this means basically that for each of these vectors, we have 20, 30, maybe 40 parameters, which we combine in some mathematical equations, and which then we reduce to one single value, which presents some aspect of business development, let's say marketing or team composition or financial position of each specific company. Altogether, we have several hundreds of parameters for each company, and which we update on weekly basis. And by doing so, we are able to find, firstly, we're able to find what are the strengths and the weaknesses of each company, what are the areas for improvement, and we can compare the each company to its closest competitors, find what differentiates them, what are competitive advantages of this company, and also we are able to assist investors in the detection of investment targets. Let's say investor wants to choose between several deep tech companies, and we're able to show what company can be proficient in some aspect which is crucial for the investor. And you can see the brief visualization of our open access algorithms of this SWOT analysis on this slide. It's kind of, it's very, you shouldn't kind of study it now in details. It's just in illustration. We will not dive into it very deeply, but the point is that we put our algorithms online, we put them open access, so they are not kind of black box thing. And we are continuing to develop our algorithms more or less on a monthly basis. And as soon as a new version of our algorithms is developed, we are releasing the previous versions open access online, and you are able kind of to study them and implement them as well. And basically here the methodology for the evaluation of AI and pharma startups is visualized. Our open access version of this methodology, proprietary version, of course, goes much deeper and has much more parameters. And basically every color, every form of the figure represents here various aspects, various mathematical aspects of our algorithms, such as mathematical transformations or parameter weights. The same, for example, is done for longevity financial industry, and the framework for this you can see in this slide. So we have here very similar SWOT analysis diagrams or star-like diagrams, which we can apply, and we are actually applying them for various deep tech industries. And the first iteration, the first version of this methodology you can observe on the slide. Well, another tool which is also important in terms of competitor analysis and the selection of investment targets we're working on is so-called smart competitor matching. It means calculation of the distance between companies in terms of their business development. So I mean the following. We have collected these parameters for each company, for each startup, and we have this, let's go back to the previous slide. We have this SWOT analysis diagrams, yes, and we can see, by comparing them, we can see what are the closest companies to a given company in terms of their business development, in terms of their finance, marketing, product, and so on. And by detecting the closest companies, we're able to find closest competitors or similar companies to invest in. And in order to find these similar companies, we use both very conventional and traditional tools, such as K-means algorithms for companies clusterization, and more advanced machine learning and artificial intelligence tools as well, such as supervised machine learning for companies clusterizations. Also, we apply convolutional neural networks for the identification of the companies with similar patterns, and we are using tech clouds to categorize them. The project is the most developed for AI and pharma industry, but we are also working on its implementation for the longevity, space tech, and neurotech. Another tool we have applied, it's interactive network diagrams. The point is here that it's crucial to define a company or investor in the context of the existing industry infrastructure. So what is the place of the company in the industry network? How does it relate to all other companies? What are the collaborations, partnerships, funding rounds, scientific operations, and so on? And reapplying here the analysis of all these collaborations, I mean, funding, R&D collaborations, team networks, in order to see what are the connections of each company with the whole industry. And it is a tool that can be applied both by investors and by large corporations in order to see what can happen with a given company in terms of its prospects of collaboration. Let's say some large pharma corporation wants to enter a deal with AI pharma startup, and it looks on what are the previous deals of this startup, what network of the connection it has, and what are its collaborators. And by doing so, it can evaluate whether this given startup is relevant and appropriate to collaborate with. Basically, all or almost all the technologies we apply here for all these tools, especially for the SWOT analysis and database extrapolation, are listed on this slide, and we can categorize them in 4 main categories. So technologies for SWOT analysis, for data aggregation, for forecasting, and for the clusterization and competitor analysis. For SWOT analysis, we apply more or less conventional mathematical tools, such as polynomial formulas and multidimensional vector spaces. It's just basically simple polynomial formulas, yes, mathematical equations with which are enhanced by 2 additions. Firstly, we have calibrated parameter weights, which reflect relative importance of each parameter in the analysis, calibrated both by experts and machine learning automated processes. And we have mathematical transformations applied to these parameters. Namely, in open access version, we have logarithmic, exponential, parabolic, and multiplicative transformations. It means, for example, if some parameter is kind of grows exponentially, we apply logarithmic transformation to it. Or if some parameter reflects network effects, such as, for example, the number of patents or other intellectual property entities, we can apply parabolic transformation for it. We also implement here what we call business development harmonization analysis, to see how different aspects of business development are aligned and balanced in the company. For example, how its financial position corresponds to its technological R&D advancement. And we apply, mostly it's done by the application of integrals here. And it's also very important here to kind of, it's very useful for the identification of overpriced or underpriced companies, because if financial position of the company is overdeveloped compared to its products, its R&D, or its team, the company may be overvalued, and vice versa. If we have strong R&D position and very strong product pipeline and small funding, just perhaps, this company can be undervalued. And for data aggregation, we apply very, very vastly various machine learning tools. Not only simple regressions, but also deep neural networks to extract value from nonlinear hidden connections. And for companies clusterization, the main tool for us is natural language processing. On the other hand, neural networks we have developed are very useful, proven to be very useful for forecasting of first and foremost of financial data, namely neural networks with LSTM layers and recurrent neural networks. Another tool, another area of our development is financial analysis of, so let's say, stock market analysis. And to conduct it, we apply Brownian models and as well as non-Gaussian models. And for clusterization and competitor analysis, we apply unsupervised machine learning, k-means algorithms, and convolutional neural networks. Speaking more about stock market analysis, both conventional econometric models and advanced artificial intelligence and deep learning tools are applied here. And it is important, speaking about deep tech industries, that we combine financial analytics with technological analytics and test, validate financial analytics by its comparison with technological. And we also conduct stock market simulations that enable us to test various trading strategies. Also, what we're working on, we are making specialized thematic stock indices dedicated to the track of specific deep tech industries. Namely, we have developed longevity stock index and AI and pharma stock index, as well as neurotech stock index, for example, where we firstly detect, identify, and list all publicly traded companies in a given industry, and then we apply portfolio optimization in order to construct stock market index with appropriate portfolio weights, and then we see its track, observe its development, and compare it to major market indices. Another option, another project we are doing by this analytics is analysis of government policies and analysis of national healthcare budget, for example. Our subsidiary company, Agent Analytics Agency, applied these tools for the comparative analysis of 50 countries to identify the factors, patterns, and parameters that determine the levels of longevity progressiveness, and to see what affects the longevity progressiveness in these countries. To summarize it, all these services can bring value for the investors and for the companies themselves, as well as for publicly traded corporations. For companies, it relates first and foremost to deep SWOT analysis of the company itself and to the analysis of its closest competitors, as well as their benchmarking and ranking. By doing so, we are also able to conduct R&D optimization and see what can be improved in the product pipeline or in the R&D process. I have also mentioned competitor matching tool, which can also be redefined as investor matching tool, which allows us to apply machine learning to match companies with prospective investors, which is investors that make similar investment decision. It means that that invest in similar companies or entities. And for the investors, both venture funds and hedge funds, let's say more conventional asset management firms, the services can be applied for portfolio optimization and for automatized data-driven due diligence. by comparing SWOT analysis diagrams of different startups that are candidates for the investments. Also, in terms of the value for the investors, these tools can be applied for the analysis of the strategies of their competitors, of what's now in development by us. It's SWOT analysis diagrams for the investors, which reflect two things basically. Firstly, their strategies, and secondly, the aspects or the features of their portfolio companies. And by making the analysis of such investors, we're able to track what is their behavior, I mean, what's their principles of investment, what are the features of successful investors, and other entities can then copy their strategies. And also it can be applied for matching with prospective companies or even with partners for the investment. So with that, yeah, I would like to close my presentation, and thank you for your attention. Contact us if you have any questions, and thank you. I don't know whether we'll have now questions session or not.
Yes, I have some questions, Iho. Like with your knowledge and also data on all these investment opportunities, would it be more, what sort of risks would you be able to mitigate using your services or your sort of AI data?
It's a question about risks. How can we mitigate risks? Yeah.
Investment.
Yeah, basically, I would divide this question in two parts: how to mitigate risks for publicly traded companies, and how to mitigate risks for venture investment for startups. Yeah, for publicly traded companies, I would say that the key point now is to apply what's called fat-tailed analysis, fat-tailed distribution for the analysis of stock market data, and I would not want to go now in very technical details, but let's say for deep tech industries we are working with, so the variance, the whole distribution is it's more wild than the distribution of common stocks, of tech stocks, and we need to pay attention to rare extreme negative events. We need to pay attention to it very carefully, and that's what we are trying to do by constructing our specialized stock indices, for example. And I would say that the key solution here is just to apply correct simulation models. I mean, not Gaussian models, but Pareto models, for example, for the analysis. And also pay attention to R&D very closely. I mean, the whole history of, for example, pharma corporations, their stock market development, it's their R&D, what they have in their pipeline, and what what clinical trials are there, and it cannot be divided from the financial analysis itself. And regarding venture capital and the risking of venture investment in these industries, I would say that this SWOT analysis diagrams and tools it must be applied. I mean, what has proven to be kind of indicator of risk is the level of the unharmonization of this business development. I probably will share once more. Okay, so to illustrate this, let me. So when the company, when the chart of the company looks very balanced, so close to the circle, it's a sign of low level of risk. Whereas if you have very developed, for example, marketing financial position, but very low product pipeline, so it's also a sign of risk and the sign of that the company, for example, is overheated. And yeah, so that's the answer.
All right. Thank you very much, Iho, for sharing, some of your insights in investing. And we look forward to, catch up again. Thank you very much, Iho.
Thank you. So
I'll be
bye.
speaking to your CEO, Dimitri, later
Yeah, I know.
in our panel. Cool. All right. Thank you, guys. And we will be back in a couple of minutes with our next speaker. Thank you.
Bye.